My name is Hemant Mahavar. I'm a program manager in Windows PowerShell team. And for the last 7+ years, I've been doing PowerShell in various forms and various features. And with me, I have
Narayanan Lakshmanan. You can call me Nana. I am a dev lead with the DSC team and have been with PowerShell for about 8 years now. So let's start with some show of hands. How many people have used PowerShell here? Good.
Awesome. You are in the right session.
And how many people use Azure? Good. What different kinds of configuration management tools do you use? It can be PowerShell, it can be anything else.
DSC, System Center, those are couple of answers we heard. That's okay. Chef is another one. Okay. Can you say it louder? Landisk.
Good.
So basically, in the talk, we'll go through why desired state configuration is a tool that you should care for. What value add does it provide? And then we are going to look into, with Azure and DSC, how they can play better together to solve your configuration management at scale. And towards the end, we are going to talk about desired state configuration as a configuration management platform for Windows. And throughout the talk, we'll not bore you with slides. We'll show you a lot of demos, a lot of PowerShell-related demos, and you will see PowerShell code that you have learned and concepts that you have learned in the last few years. So we'll start directly with demo. See, I told you we'll see demos. So here is a PowerShell, not exactly PowerShell script, but in a PowerShell file, a VB script. And what this script does is it creates an SMB share. And just trying to fit this script in a screen, it goes all the way here. Now, you guys can read all those 95 lines and understand what it's doing, right? So that was the world before PowerShell. Now, in Windows 7 came PowerShell. And here you will see the mix of .NET, WMI, and PowerShell to create the same SMB share using 20 lines. Some progress made. Automation becomes easier, easy to understand maybe. And then in Windows Server 2012, those 20 lines became 1 line. Claps, please. Now, how many of you use this 1 line in your production environment? Just this 1 line. Okay, you are brave. Because what happens in production is that 1 line transforms into a lot of lines. You have to do error handling. You have to check if the share already exists or not before trying to create it, and check its permissions. So again, that thing goes back to about 95 lines, but now it's robust. It is going to work all the time. So that is how things have progressed. Now comes DSC. Simple, easy to read, easy to understand. The intent that you want to do of creating SMB share is captured in these 19 lines. And I can bet anybody who has not used PowerShell and knows SMB share, knows what it takes, can read it and understand it. So that is what DSC brings to the table. Simplification in a very declarative way and captures your intent as a configuration. So that was first demo, what DSC brings to the table. We'll see more of it throughout the slides, throughout the session. Now let's talk about life in cloud. Everybody is moving to cloud. There's a lot of virtualization happening. And cloud is essentially needed for scale. Businesses are growing. You want to scale. Scale means you have more infrastructure to manage, more servers. That means you will have more failures. Additionally, your applications are becoming complicated. They are more complex. So given this multiplication of scale and complexity, that exceeds current IT pros' skills. And the rate at which these things are growing, the skill set cannot grow with the same pace. So that's one aspect. The other aspect is people want to reach to the market faster. They want to capture the market faster. And what does that mean? That means you are churning the code faster. You are making a lot of commits, a lot of change on a daily basis. And again, that's another point which can cause failures. And I think everybody here will agree, when things break, they break because something changed. And this combination essentially leads to rapid change at scale with constant failure from a management perspective in cloud. And that's where DSC comes. It simplifies your complexity to a certain extent so you can scale and keep making changes at a rapid pace.
So, how does DSC help us here? As we saw, in a traditional script, you would have everything defined in the script. What your intent is, what is the dependency resolution, logging, error handling, the technology specific code, everything is in a single script or a set of scripts. And then when we enter into DSC, we separate them out. You write configurations which describe the intent. And then there are resources which are pluggable, and that deals with the technology specific implementation. These resources are PowerShell scripts themselves. And everything in between is handled by the DSC engine. So it gives you nice layering. Most of the redundant stuff about logging, error handling, reboot resiliency, etc., the engine takes care of, and you can write lots and lots of configurations, and your system is configured the way you want it. So, what does DSC give us? It simplifies configuration. It enables you to define your configuration in a declarative way. And it prevents configuration drift. Once you configure something, and let's say there is an unintended change, then DSC can either automatically correct it, or it can correct based on your trigger, and that's a choice you can make. But DSC can correct the configuration drift. And it enables continuous deployment. You can continuously deliver your application, and not only that, it enables you to take the application from development to test to production, and thereby enabling you to establish a deployment pipeline. So let us look at a demo, right? Let's start with your best buddies, developers. So let's say a dev asks for a VM, and in the VM you want a web application deployed, and you want to hand it over to the dev. So we start defining the configuration in DSC. Configuration is like a function, so you specify the configuration keyword and the name of the configuration, and then a node statement. Now this is the list of computers or nodes where you want the configuration to be deployed. So I want this in web server 1, and then this is a simple web application. So I want the Windows feature with name web server to be present. And then I want a Windows feature, ASP.NET, to be present. So this is a simple configuration. And now let me run this.
And you will notice you expressed your intent. You never specified how that action should take. You just said, I want these two features to be installed. Make it so.
And in PowerShell, now there is a new command type called configuration. So if I do get command, configuration, then I see my fourth coffee website is available. Now, this is invoked like any function. So you define a function, and then you invoke it. Similarly, you define a configuration, and then you invoke it. And let's see what happens.
So essentially, when Nana ran the thing, it did produce an error, but it actually created the configuration. And that is the MOF file.
So what happens here is, when the configuration is invoked, it produces what we call as a configuration document. So you author a script with a configuration, and then when it invoked, it produces a configuration document with a .mof extension. Now, what this essentially contains is all of the PowerShell variables and iterations, etc., expanded, and you get this document, which then gets deployed. And the way to deploy a configuration, like anything else in PowerShell, we have a commandlet. It's called start DSC configuration. You specify the path to the folder where the MOF files or the configuration documents are present. You specify which computer to deploy that to. Now, typically, configurations are long-running, and therefore, the commandlet actually outputs a job object. But for testing or for a demo purpose like this, you can use the -wait parameter to get all of the output interactively on the console. So now this begins the configuration of the VM that I have already created. As you see here, it is doing something like start test, start set, etc. So what exactly is happening? So this is how the Windows feature resource looks like. It is yet another PowerShell script that basically defines three functions: a get target resource, set target resource, and test target resource. Essentially, test tells me if the resource of interest is in the desired state. So in this case, it tells whether IIS is installed or not, because we want it to be installed. And if it is not in the desired state, then DSC invokes the set function, which actually makes it happen. So the set is responsible for ensuring that IIS is present.
And one thing you will notice, we started the configuration, and then while it was running, we went into the make it so phase, what happens under the covers. So we are showing you both the intent and the make it so phase in those slides, in those scripts.
And so here you see start test, and then there is start set. Because IIS is not installed, it goes ahead and installs IIS. And similarly, it does the same for ASP. If you look at this configuration, this doesn't look like PowerShell, right? It has a hard-coded computer name, no parameters. not really useful. But as I said earlier, a configuration is like a function, and it can have a parameter block. So it can take any number of parameters.
And not only that, you can apply all the learnings that you have done from last few years about validation on parameters, validate whether they are null or empty, validate set, all those things you don't have to forget, you don't have to learn something new, you can just reuse it again.
And so here I use the parameters inside my configuration. So now this configuration has the node name passed in. Also, I am building the configuration on top of what I did. So we had web server installed, and now I want the default website stopped. And stopping a website does not make any sense if the web server is not installed. So I build a dependency using the depends on statement. So I say the website depends on Windows feature IIS. So essentially what this means is, for whatever reason, if IIS is not installed, or if the installation runs into an error, this piece of the configuration is never enforced. So DSC will not attempt doing this operation because you have declared a dependency. And then I talk about, I want the website contents deployed, and then I actually want my website or my web application endpoint set up in the configuration.
So Nana, when you ran the previous configuration, what does that web server looks like?
So let's take a look. So here is my web server 1. This just has basic IIS in it. My web application is not deployed. So now I'm going to invoke the configuration that I've extended and parameterized. And then in this case, if you look at here, it says skip set. So essentially, when the configuration is reapplied, now DSC calls test, and it detects that IIS is already available, and therefore it is skipping that and moving on to the next resource. So you can gradually build your configuration, apply it over and over again without having to worry about where you left and where you want to start. You always start from the beginning and you proceed.
And this model enables you to say, hey, I started something and I have to go for a meeting, come back, I don't have to remember. I go for a coffee, I don't have to remember what I did before. I can come and run the same configuration again. If something needs to be done, it will happen.
So now I refresh, and here is the fourth coffee website that we deployed. We always found that every cafeteria has coffee but no cupcakes, so we developed an application for the same.
Okay. So that was how you can simply express your intent and write a configuration document to deploy a website. And as Nana talked before, we are going to take you through the continuous deployment or release pipeline cycles, and what he just did was the development phase. Now, really, when something like this happens, and I as a program manager or I as somebody presenting, I run into an issue, and I go and say, hey dev, can you fix the issue? They says, yes, fixed, you're good to go. And then I'm still not sure it's good to go because I don't even know what they did. Maybe they put a breakpoint, maybe they turn on a debugger. So how do you gain confidence, even if you trust somebody like Nana, that the system is in the right state?
So Hemant is right. As a dev, whenever you get a machine for debugging, intuition tells me you got to mess around with it. Let me see. So I get into the Fourth Coffee website, and as part of debugging, I change something, forget to put it back, and then hand over the machine. Now what happens? Suddenly all the cupcakes disappear.
And I am a very cheap person. I want to see what I'm getting for $5.99 before buying it.
So here is where DSC's configuration drift autocorrection comes in. In DSC, you can specify that you want any drift automatically corrected. Now, the default option is DSC will detect if there is a drift, and it will report in the log files. But you can change that to say automatically corrected, and the next time DSC does a scan, it is going to detect that there is a change and it's going to fix it. And for the purpose of the demo, I am going to invoke that explicitly using a function just to get a feel of how that moves. And in the DSC world, we call this a consistency check. So now that it's done, you see the application is configured back to how we wanted it to be, and everything is fine. At this point, I think I can really say development is done.
And I would agree there. So what Nana just showed you is DSC engine has a way to run the configuration periodically on the node in the background, and if there is a drift, you have an option to tell it to autocorrect it or get that information from the log. So now when development phase is really done, let's see how we can make it better so we can use the same concept across different stages. So now I'll put the hat of a developer/tester. So this is the Fourth Coffee configuration that we have been using so far. There is something funky on line 6. You will notice that we have a magic variable, all $all nodes, and we are doing some kind of a filtering. And another thing you will notice, what we saw in the previous demo, all the parameters that were on the configuration block are gone. And what we have done is we have separated those into a different file. And then you will wonder why. So when you are moving from one stage to another stage, you want to minimize your change. So this file where you're expressing your intent, you're capturing how does the structure look like. It's the structural configuration. You want the same website, same content to be deployed in dev or in test or in production. But maybe the machine names will change. Maybe the location where you get the source of website content, that will change. Maybe the name will change. Things that are going to change based on your environment, you put that in this configuration data file, or what we refer it as environmental configuration. So now I've taken your intent and separated into two files, structural configuration and environmental configuration. You change environmental configuration as you change your environment.
And we all know this, that anytime there is a problem in production, there is always a conflict between the devs and the IT pros. And the reason is simple. In most cases, how the dev environment is configured is very different from how the actual production environment is configured. And what this helps us do is retain the same structural configuration, keep changing the environment, and redeploy the same configuration across the deployment pipeline.
So let's go and run the script. And you will see it will go very fast because the machine is in the right state. And the idea here is separation of your configuration into a structural and environmental helps you make transition smooth across environments. Now back to slides.
So DSC decouples the intent from the make it so. Make it so is the how part. These are the pluggable DSC resources that does the heavy lifting for a particular technology specific component in an idempotent way. That is, you apply it over and over again and it does not have any unintended consequences. And then the intent is separated into the what, or what we call the structural configuration. I need IIS, I need ASP, I need my website contents deployed, and so on, right? That's the what part of it. And then comes the where, or what we call as the environmental configuration. Where do we want it? I want it in this VM here locally. I want it in the next VM here in my test environment, or I want it in Azure. We separate the environment from the actual structure of the configuration. So what exactly does DSC enable? It enables configuration as code. Similar to compilation, you can detect conflicts before deploying them. And as we saw, there can be a single source for multiple environments. And DSC enables DevOps. You can check in your configuration along with your application source code. So every time there is a continuous deployment happening, you know which version of the configuration corresponds to which version of the code. So what that enables is, at any given point in time, you can deploy whichever version of the application you want. You want to keep moving forward, you can keep doing that. For whatever reason you want to roll back, you know which version to roll to and what is the configuration for that particular version. So you can seamlessly move back and forth and therefore be more agile and make more continuous changes to your application. And given the way we author resources, it drastically reduces complexity, and this model helps us to bring up or tear down systems based on the demand.
So far we have talked about what value add DSC brings. And now let's look at how DSC and Azure play together and give you a better together story. So everybody knows what Azure and cloud provides in terms of scale, elasticity, dynamic provision. Along with that, if you have the notion of using same configuration at different environments, you can apply that to get a larger scale. I will do the same thing on my DevOps, and when I go to Azure at scale, I can take that same configuration and apply to my Azure environment. And that's not all. With Azure extension model, you can now plug in DSC to do dynamic configuration and provisioning at the time of VM creations. And lastly, everybody knows Azure provides you multi-tenancy and isolation per subscription. With DSC and Azure together, now you have a multi-tenant isolation-related configuration management story which works at scale. So let's go and see how that can happen when we move from a development cycle to a test cycle or a test pipeline in Azure.
So we did the Fourth Coffee website on a local VM, and let's assume that your test environment is in Azure. So here I have two VMs already created in Azure, and now let's look at how to deploy this configuration onto those VMs. If you look at the structural configuration by design, nothing has changed. It's the same configuration that we used for the local case. However, now I change my environmental data. The node name is the fully qualified name of the Azure host. Rest all are almost same, if not for a change in folder here and there. Before we proceed, one of the things to look at is DSC uses WinRM service and the WS management protocol to communicate between the client and the target nodes. This is the same protocol that's used by PowerShell remoting and by SIM. In Azure, the VMs publicly do not have the same port on which the application or a service runs. So I'm going to use the get Azure WinRM URI. That's a commandlet available that tells me which port the WinRM service is running. So let's do that. So I see that it is running in 5132. And as you see, I'm using a PowerShell 1.0 concept, dash out variable WinRM URI, so that's available in a variable for me to use further. Then the invocation is going to remain the same. The name of the configuration, pass in the configuration data, and where do I want the MOF files to be generated. So now let's look at how do we invoke. There is a slight variation in how we deploy the configuration. Given that the VM is sitting in Azure, we got to use HTTPS or SSL to communicate. And how do we do that? We create a SIM session. So we use the new SIM session commandlet, pass in the computer name, which is the full name, fourthcoffee80.cloudapp.net, specify the port that we just discovered using get Azure WinRM URI, and then specify a session option object. Now that's created using the new SIM session option commandlet, where I can specify I need to use SSL. Once you specify that and the credentials, you can create a SIM session to the Azure VM. So let's do that. It prompts me for the password. So here is my SIM session. Once that is established, we use the same start DSC configuration, but instead of the computer name, we specify the session we just created. The rest of the parameters are the same. So let's invoke it. Let's run the whole script.
So what happened was the configuration was not imported, so it failed to find it. So we are running the entire script.
Yeah. I was moving between ISE sessions, so it didn't have the configuration defined. Okay, there you go. Now, the same configuration, which is setting up the Fourth Coffee website, is happening on a VM that I have created in Azure. And just to speed up things, I already pre-created it with IIS, but you can see that it is deploying the website contents from the verbose logs here. Let's take a look at that. Oops.
What happened to my cupcake, Nana?
There you go. That was just a cached page. So here is the Fourth Coffee website application, gone from dev stage in the pipeline, which was in a local VM, to the test environment, which actually happens in Azure.
And we can put a checkbox on that test phase as well.
So now, let us look at how to take this and deploy into production. Given that development is done, testing is done, and everything is good, there is absolutely no reason to be interacting with the VM. And what Hemant is going to now show us is how do we use the Azure script extensions to automatically provision and configure the VM so it can go live into production.
Okay, so just a heads up, I'm going to create a VM live. It's going to take long, and we'll kick off the demo, and then I'll go through the slides and actual code that is going to do the work or heavy lifting. So we started the demo. It's copying some stuff to the blob, and it's going to create the VM. So let's look at what's happening under the covers. So essentially what's happening is it is publishing two things to the blob. First, as Nana mentioned, Azure has a notion of custom script extension. We are going to leverage that and give it a configuration, our familiar fourth coffee configuration, IIS, ASP.NET, creating the fourth coffee content. And in the blob, first we are going to copy a DSC bootstrapper script. And essentially, this is the script which that custom script extension is going to download and invoke to call DSC. That script extension can call any script, and that script can do anything. In this case, we are not going to format anything. We are going to call DSC and say, make it so. The second piece that demo does it takes that configuration and puts to the blob. There are various ways you can do that, but this is making sure the data reaches the blob.
So essentially, that is setting up a central repository. So you take all the configurations of interest, put it up in the blob, so different VMs can now fetch from that central repository.
So once that's done, now we are going to create an Azure VM with script extension turned on. That's something that was announced today in the afternoon, that in Azure portal now you have an option to pick the custom script extension. And I'll show you again that in a few minutes. And we tell script extension to go to the blob, download that DSC bootstrapper, it downloads it, it invokes it. And what does that DSC bootstrapper do? It goes back to the blob and says, hey, for this machine, give me its configuration. It downloads that configuration. Now, it not only just downloads the configuration, it parses it. It uses PowerShell API, not your grep and not your select string kind of stuff. PowerShell API, structure object, and finds out what DSC resources are not on the box. For my demo, I'm using Windows Server 2012 R2 VHD. So it comes with built-in resources. It does not have X web administration resource. So it's going to parse it, find out what's missing.
So that is one of the aspects of DSC. Before it starts to configure, it looks at the document and ensures does it have all the required resources and modules so it can actually enact the configuration of interest.
So after it parses, it goes to a resource gallery. That resource gallery contains the resources needed for the configuration progress. It downloads it, and now your system has all the DSC resources needed for that configuration. It could be one PowerShell module wrapping the DSC resource, or it could be 10. And once everything is there, the script is going to invoke that configuration. So that is one piece of how the demo flows, or what it's doing under the covers. The second piece is,
you switched to mine.
Wrong one. I'll show you something and you'll not see it. So this is the virtual machine configuration in Azure, where you can select custom script. It allows you to pick up a script from your local machine or from Azure Blob. And you can even pass arguments to that script. And this comes up as part of configuration extension that Azure VM enables. And while the demo is running, let me talk a little bit about what that resource gallery is and how it works. So you guys are few of those who are getting a sneak preview of Windows Management Framework 5.0 May release. So you are the first few of those. There is a module called PowerShell Get. How many of you have already heard about OneGet? Okay, now you can connect the dot. OneGet, PowerShell Get, NuGet. So it is there, it's not imported. So I have PowerShell Get, and what it gives me is commands from module PowerShell Get. And now you have ability to find various modules from the resource repository. You can install them. You can publish things to those repositories. And not only that, on your system, you can update existing modules. So that is what PowerShell Get brings to the table.
You don't have to get to a browser anymore to download or upload modules from a repository.
So let's invoke find module. It's going to make a connection to resource gallery, find all the modules with their version, the date they were published, and description. And you will see here you have regular modules, you have modules from your favorite MVPs and community people, as well as DSC resources. As long as it's module, it will find it, it can download it, it can install it.
The connection between a DSC resource and a module is a DSC resource is shipped like any other artifact in PowerShell contained in a module. So a module can contain commandlets, functions, alias, etc., etc. And now a module can also contain DSC resources in it.
So what I'm going to do is download a module which is a DSC resource for OneGet. And you go and invoke it. I forgot to set dash verbose. And it tells where it's going to install. Since it's already installed, it tells you the version 1 is there. Okay, so here we ran into a demo bug. It was supposed to give back the progress, what happened on the Azure VM. So let's go back to the VM. Here is the demo VM. And let me go and try to open. Oh, it's still doing something under the covers. So while that's happening, or not happening, let's look into how does I leverage, or how can I leverage the feature about OneGet. So once I installed the X1Get resource, now I can use PowerShell looping construct like for each and install packages on my system. So it's not just about configuring your machine from an application perspective. It's also about downloading the packages and modules that you use regularly. And installing these things is going to take time. So what I have done is I have already installed. So you will see the make it so or idempotent phase of DSC. So it's going to compile as a local machine, is going to run. And what happens under the covers is that OneGet resource has a chocolatey provider. All these modules are present, or all these packages are present in the chocolatey repository. That's where we are starting. That's the direction. That's not the destination. That's the direction we are heading. That's what you are going to get. And another thing that I forgot to show is what does the demo actually is doing. So here is the configuration that I ran on the Azure VM. I publish the configuration and the bootstrapper to the blob, and then using the power of PowerShell pipelines, I'm going to create a Azure VM. I'm going to, not going to, it failed already. Define what size of VM you want, what VHD you want to use along with it, set up the username password for the admin account, and this is the non-UI way, the PowerShell way of turning on the custom script extension. You tell what accounts to use, what container, what Azure container to go or Azure blob to go to, name of the files you want to download. In this case, it is DSC boot and settings file, and which one to invoke. So this is the piece which allows the VM to go, download, and invoke the custom script extension. And in the past, in the previous demo, Nana talked about how does the mapping of port happens. What I did from a web server perspective is I said map the local port 80 of that VM to the service port 80. So I don't have to specify the port numbers. And finally, you take all these data that is coming through various pipelines and says, create me an Azure VM and wait for its boot to finish. And now let's look at what's happening in that DSC boot script. So DSC boot script goes and downloads the modules using get blob content. It says, go download the module if there's any needed for system modules. Go and download the configuration. Once you download the configuration, you go and find the custom modules. Find configuration about import modules from that script.
So this is where it is parsing and finding out which are the resources that this particular configuration needs, and then tries to establish the connection back to the blob and fetch all of those resources and download them.
And then essentially we use install module to go to the gallery and download those custom modules. And once all that is done, then we say go and invoke start DSC configuration locally on that VM by the DSC boot script. Let's give one more try if it doesn't work well. And we are going to publish all these scripts on PowerShell blog either this week or a week later. And then the only thing that you have to change is your subscription about Azure VM, and you can run this demo and have things ready in Azure.
All the VMs that we created for this demo, both on our local machines as well as on Azure, we did that using the script extension and DSC. And we will make that public. You can consume the same and create VMs at will.
Okay, so that finishes the third piece and the last piece of production environment in continuous deployment. So we went through development, test, and production, took the same configuration, made slight change in the configuration data as it flows across environment, and used Azure VM script extension to provision and configure at the boot time.
Okay, now let's look at how DSC plays as a configuration management platform. So we have the DSC engine, and if we looked at all of our demos, what we did was we invoked DSC from PowerShell, and the engine in turn used a bunch of resources to configure a system. However, any UI or other third-party tools can invoke the DSC engine similarly, and it can produce a MAF document, it can supply a MAF document, and the DSC engine can consume the same. That is one of the reasons why there is the PowerShell element which then gets translated to a MAF representation. So third-party tools can also generate MAF, for example, in a different way, and then supply them to DSC. Also, there are other aspects of DSC where third-party configuration management tools can plug in. For instance, they will be able to supply their own logging mechanism, change the reporting structure, so on and so forth. One of the interesting aspects is third parties can write adapters and make DSC resources show up as their own resources in their environment. So as developers, if you choose to write configuration management artifacts, then it is advisable to do that as DSC resources, because the configuration management story for Windows moving forward is more going to be aligned in terms of DSC, and therefore any third-party configuration management tool, we expect that to be aligned, and it's advisable you use tools that are aligned with the DSC strategy for Windows.
So with that story about DSC as configuration management platform, let me welcome Julian Dunn from Chef to show you how Chef and DSC can play together and provide you with an option of choosing your configuration management tool.
Thanks, Heyman. How many folks know what Chef? Thank you. How many folks know what Chef is already? Wow, that's a good show of hands. How many people are using Chef to manage their Windows infrastructure? Okay, that's pretty good. So how many folks were actually here last year when I had a demo go wrong and I clicked the wrong button? Okay, so I'll try not to do that again this year, and actually I'll start by doing the same thing by going through our fancy new web interface, in which I'm going to add the Fourth Coffee website to an Azure VM that I've already provisioned. It has a base image on there, but it doesn't have any of the components installed. No IIS, no .NET, nothing like that, none of the website content. I'm going to do the exact same thing. That, of course, is going to take a little bit of time, and so then I can talk through a little bit, and I can show you the code and show you under the hood while it's running, and we'll see if it finishes by the time I'm actually done that. So the node that I'm going to add this to is DSC Demo 2. And as you can see in Chef, you have a run list, which is a list of things that machine is going to do. And as you can see, I've got a run list that really has just nothing more than a base, what I run on Azure as my base run list, which is, make sure the Win32 time service is running, and make sure the WS-man ports are open, and all that kind of housekeeping stuff. That's basically how I set up my Azure boxes. And then down here, I should have in this long list, somewhere in here, I should have a Fourth Coffee website. There we go. So let's put that over here in the right order this time, unlike last year. Okay, and if I save that, now what I'm going to do is normally the Chef client, so what I did when I brought up the Azure VM is I actually used the custom extension that these folks were showing. If you were paying attention to that screen where there were the custom extensions, you saw there was a script, and then right above that you saw there was a Chef extension. Now if you click that button and then you put in your credentials for Chef, it'll go through and it'll provision that machine and do the configuration with Chef on that box instead of using a custom script. So that's how I set up my Azure VMs. So normally that also sets up Azure, also sets up the machine to run Chef client on an interval. So again, it's checking in and making those changes. But again, for the purposes of the demo, what I'm going to do is just log into that box, and I'm going to run Chef client myself. Okay, so that's going to start. And then while that's running, because that's going to take a little bit of time, I guess I'll just talk to you a little bit about Chef and PowerShell. What's this doing? Okay, Chef and PowerShell DSC integration. So again, if you don't know what Chef is very, very similar to DSC, actually. You can also think of it as infrastructure as code, right? Also declarative. You're also declaring your end system state. You're saying the what, not how to actually do it, right? What we do is we also do the make it so part of it, right? So it's also declarative. It's cross-platform. So it works on Windows as well as many other operating systems. And there's a really rich, one of the great things about the Chef community, there's a really great and rich tool chain around, if your infrastructure is code, you can now test that code, right? So you can now take, again, a lot of the practices from developers that folks have already created in that universe, right? Unit testing, integration testing. You can steal those practices and move them into your operations space, right? So we have a really great tool chain around, formal testing and verification of your, what we call our recipes. That's your configuration code, and testing it to make sure that it all works and make assertions before you go to production and you break things, right? So some of the use cases are, it's a configuration management platform, so it's not only about the configuration management, but of course it's the same thing that Heyman and Nana were talking about. It's about your application deployment, it's about your continuous delivery, right? It's about DevOps. So you can see some of the syntax, the examples here are, well, on Windows, you might say something like Windows feature and install a web server, right? And then the similar code, the analog on maybe a Unix platform would be, well, their web server is called HTTPD. So you would write a very, very similar type of code to install that. Now, what we're showing today is all these DSC resources that are coming out of the box and all the DSC resources that developers are writing and creating, right? Whether it's in the resource kit with a lot of this X-Web administration stuff or any of the modules that we saw on that gallery, right, they can be invoked directly from Chef as a one-to-one mapping of resources, right? So how you might say import module, blah, 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 right, you would say include DSC within your Chef context. And then, you could have, we basically have a mapping between the actual functions within DSC and how that code would appear in a Chef context, right? So you have Windows feature and IIS, and again, we have some mapping rules to deal with reserved words to make sure that they don't conflict with things that are already built into the Chef language, but we have DSC name web server and DSC ensure is present. What you can also do is you can mix and match, right? You can mix and match here. If you already have some Chef code to do various things, right? Chef already comes out of the box with a lot of really interesting resources for managing things like users, groups, getting files off web servers, this kind of stuff. You can mix and match if you already have some code. You can mix and match your DSC and your regular Chef code, right? So you might say, hey, I'm going to use the DSC resource to Windows feature resource to install IIS, make sure that it's present. But maybe I want to use the existing IIS cookbook to set up my app pool to deploy my website, right? Maybe I'm like, I don't really like the fact that there's an X prefix to these extensions. I'm not comfortable with that yet, so maybe I'll use something else that I already know works, right? And the good thing about Chef is, that management portal that I showed you before. When the Chef client runs and makes those changes, or maybe when it doesn't make those changes, you can inspect the state of those runs. What changed, what didn't, with a really graphical interface, right? So you have this when you run Chef, and maybe we'll see it if that run finishes in time. At the end of it, there's a GUID that corresponds to a run ID, which you can then look up in our monitoring the control panel, right, and see what happened during that run, see what errors there were, see what resources are actually applied on that box. And of course, we have some pretty graphs as GUIs need to have, right? And just finally, as an overall summary, that's kind of what I showed you before, or what I was talking about before, the extension in Azure, right? Being able to go, instead of using custom script, you can use Chef to provision that. And that picture is actually Mark Rusinovich, who is, if you folks are, Windows folks, obviously he wrote all the sysinternal stuff, and he was demoing this integration at our conference a couple of weeks ago at ChefConf. That's pretty cool, and you can come by our booth in 747, like the airplane, very easy to remember, and you can watch that video and talk to us about that. And Microsoft is also contributing really great, a lot of stuff to the Chef community by developing cookbooks to run on Chef and helping us with the technical documentation. And we're doing these integrations not only with DSC, but with Azure generally and with Windows. And we've been working together at Build and ChefConf and stuff like that. So it's a really exciting time. And what I did want to do is to show you the code of how I mapped this Fourth Coffee website. So on the right here, you'll see that that's basically the code that Nana and Heman were showing before, right? With the website that they were standing up, and that's a PowerShell script. And on the left-hand side is what I took is I translated what they wrote into native Chef code. So you can see again, the ordering is the same, the syntax is very similar, right? It's got the same kinds of assertions in a declarative manner about the systems, about how you set up the system. And I can post this code as well later. All right, let's check in on our machine. See if it's done. Looks like it's done. So let's go to IE. Oops. And there we go. And I took the liberty of substituting some cookies that our CEO's wife baked for us because I've had a lot of cupcakes. I'm from New York, and cupcakes are the hot thing, and so I decided I'd like to have some cookies. So please enjoy some cookies courtesy of Chef. Thanks very much.
Thank you, Julian.
So thanks, Julian. So as you saw, a DSC resource gets translated into a native resource in Chef. So if developers develop DSC resources on Windows, then Chef is a great choice of a configuration management tool because it leverages DSC as a platform, and most of the management artifacts can then be reused.
And just to reemphasize what we talked before Chef demo is, if you are picking up a configuration management tool, you make sure that they have a strategy to align with desired state configuration for configuring Windows. That's the direction Microsoft is heading to. And if you pick up a tool and put all your investment which doesn't align, it might not work well in the long run.
So to recap, DSC simplifies your configuration. It enables you to declare your intent. It prevents a configuration drift and can correct the same. It enables the continuous deployment pipeline. And interestingly, it tattoos the system with the configuration from the provisioning stage, and your system can go live in Azure.
And that brings us towards the end of the session. We have a couple of related talks happening throughout Decade. There are 2 or 3 talks I would like to call out. There is a talk which shows you how Visual Studio release pipeline is going to use DSC for configuration management. You will hear from Jeffrey how you can use PowerShell DSC and other PowerShell features to create a toolkit to have a secure environment.
And take a look at that title. You don't want to miss it.
That's number 3. And on Thursday, there is a talk about how Hyper-V Recovery Manager is aligning with desired state configuration to do disaster recovery. When they move from a primary data center to a secondary data center, the configuration, enactment, and enforcement is going to happen with DSC. And for people like me who are greedy, if this set of contents are not enough, here are the list of contents or sessions which are going to talk about PowerShell in some way or form. And out of you who are counting, the number is not 10, not 20, not 40, it's 52. And additionally, we have hands-on lab about how to learn about DSC. We did that one today afternoon. There will be one tomorrow, as well as hands-on labs and instructor-led labs about PowerShell fundamentals. And as usual, you will find a lot of us, along with our wonderful PowerShell MVPs and folks from our management chain, at our booth, at Scripting Guy's booth, as well as Ask the Expert session on our meeting on Tuesday. And lastly, you have various resources, but the thing that we thrive a lot, and it's a win-win, where you get to win some prizes, is when you fill out your evaluations. You tell us how can we make the content better, whether you want to hear more of Hemant and Nana, or you want to hear more of Jeffrey in next couple of conferences, and what is the feedback you have. As Jeffrey keeps talking, anytime you give us a positive feedback, it makes us good. When you give us negative feedback, it makes us better. So be nice on the evaluation. Don't always give negative ones. But thank you, guys. And we'll take questions. We have about 5-10 minutes.
Quick question on the script injection with bootstrapping in Azure. Is that something that will be extended out through like Windows Azure Pack here in an upcoming release?
So I don't know the official answer whether it will be part of Windows Azure Pack, but definitely they already have command list to do that. And if you look the way things have happened in the past, you won't be surprised to see if it comes at Windows Azure Pack.
Okay, thank you.
Hey, Hemant.
You guys are making my head dizzy. Between DSC and SMA and orchestrated changes via VMM 2012 R2, I could do the same task 3 different ways. Can you, as Microsoft representatives, tell me the direction? Where should I focus? Because I'm not going to be able to do all 3.
So when you say 3, you have DSC, you have SMA, what's the third one?
VMM 2012 R2 with orchestrated changes. So, for example, with self-service, a developer could put in a ticket, it goes into Service Manager, it'll kick off an orchestrated change that would add that website, that would... So a couple of different ways we can do this.
Right.
Which way Microsoft wants us to focus?
So maybe Jeffrey has better answer than me here, but it's not one over the other. It's the combination. Okay. Because what our SMA provides you, it provides you a way to do orchestration. When you have a large system, you want to say, do something here, once it's done, do something there. So that's a orchestration tool. When you want to say, my machine should look like this, that's where DSC comes and plays a role. DSC has capability to say, the truth about the machine state stays on the machine. It can be enacted over and over again by the machine itself using the DSC engine. Orchestration through SMA is an external entity that you use to make sure you set up the environment. Jeffrey, that's...
Hey Hemant, hi, this is Vineet. So I had a question regarding DSC and how does it handle restart of a computer. So let's take a case like I have a Hyper-V server. I create a PowerShell DSC module to install Hyper-V role, configure the virtual networks, and it goes for a reboot. So what if the server doesn't come up, or do we specify something like a restart computer -wait parameter?
So good. Like that? So the question is, how does DSC handles reboot? Because when you're configuring, a reboot is required. So essentially, DSC has an engine setting which says allow machine reboot if needed. You set it to true. By default, it's not true. And what DSC will do is it'll say, hey, run this. If resource tells me to reboot, I'll reboot. And after reboot, without you coming into picture, it's going to apply the same configuration all over again. Since it's idempotent, it will do the test. What's done is done. What's not done is going to go and do the set. And since DSC engine runs as a local service, you don't even have to log on or interact. You can do it, go home, have fun time, come back, your system in the right state.
So essentially, DSC understands that a configuration is not done, and after reboot, it needs to move forward. And irrespective of whether DSC reboots the node or if we externally reboot, if DSC detects that it needs to proceed forward, it will do so, reboot again and again until it eventually converges and reaches the desired state.
Okay, that's nice. So that's one query I had. So I work as a part of the Bangalore PowerShell user group with Ravi. So I think Alexander, you know me. So this is one question I asked Ravi, but he thought he told me he would check it out. So I thought I'd come here and directly ask you guys.
Thank you for that.
Thanks a lot.
Question.
I noticed you guys were talking a lot about environment configuration, but I wanted to know if DSC would be beneficial for starting the user from the ground up. So we got a new user, so we got an Active Directory configuration, SMB share configuration, Microsoft Virtual Machine dedicate the pool to the user in the configuration. Can DSC govern that? And if it can, how does it compare in performance when it comes to Orchestrator?
So DSC can do all of these, except if you want DSC to perform something as a user, then there is a little bit of working around that needs to be done. The reason is the DSC engine runs under the local service context, and therefore it cannot access the user's My Documents or HKCU kind of things. But we have had resources that take a credential and impersonate a user and get those things done. So Does that help? Yeah. Thanks.
Everything you've talked about has been about managing and configuring VMs. What about using DSC to configure worker roles in a more PaaS-style deployment?
So, one of the problems, you can think of it as a problem or a solution depending on how you view it, but DSC requires that the configuration run in a node. Now, the way we set up Azure VMs is we run it locally and in turn have the resources talk to the Azure endpoint to provision the VMs. You can use a similar approach to configure anything in PaaS, but that requires that you have a node to which you apply, and the node acts like a proxy.
So having a notion of a proxy machine where once you give it the document or the configuration, which is essentially not meant for that machine, but the resources then go out and configure the entire environment.
So that's the way you would do PaaS kind of.
PaaS scenario where you're talking to a service, there's no entity or no single machine that you can talk to. And that's where you will have a notion of a proxy to say, I'm going to talk to.
Right, but I still have the same kind of boot time configuration that you have on the VM, right? You've got the bootstrap in the VM that goes out and does all these things. I have the same kind of start process that happens in a worker role when it initiates. Correct?
Yes, I don't know the answer.
I'm not sure either, because we know that VMs do have this extension facility that we can leverage. I'm not very sure about what happens in the PaaS world there.
That makes sense. Thanks.
Yeah, quick question. We use web deploy packages to deploy websites. Is there any thought of supporting that in DSC?
So, yes, there has been thoughts about a lot of different things that we want to write resources for. So we have started that journey with REST kits. We started with 12 in box, now we have reached 50. And if you look what community has done on the GitHub PowerShell.org resources, that number is increasing. So it's just a matter of time when we can reach there and say, oh, we have a resource which models the web deploy.
Yeah, that's what I'm doing today. I just want to see if there's something.
I mean, you can actually look.
What's that? I probably will write one. I think the problem with the PowerShell is it doesn't have the sync abilities as well as the web deploy, command line. No, I know I don't know if you know about all the bugs with calling web deploy from PowerShell. It's a real nightmare. Yeah, I might have to write one, so I'll look into it.
Okay, thank you. Now, how many of you use this one line in your production environment? Just this one line. Okay, you are brave. Because what happens in production is that one line transforms into a lot of lines. You have to do error handling. You have to check if the share already exists or not before trying to create it, and check its permissions. So again, that thing goes back to about 95 lines, but now it's robust. It is going to work all the time. So that is how things have progressed. Now comes DSC. Simple, easy to read, easy to understand. The intent that you want to do of creating SMB share is captured in these 19th line. And I can bet anybody who has not used PowerShell and knows SMB share, knows what it takes, can read it and understand it. So that is what DSC brings to the table. Simplification in a very declarative way and captures your intent as a configuration. So that was first demo, what DSC brings to the table. We'll see more of it throughout the slides, throughout the session. Now, my name is Hemant Mahavar. I'm a program manager in Windows PowerShell team. And for last 7+ years, I've been doing PowerShell in various forms and various features. And with me, I have
Narayanan Lakshmanan. You can call me Nana. I am a dev lead with the DSC team and have been with PowerShell for about 8 years now. So let's start with some show of hands. How many people have used PowerShell here? Good.
Awesome. You are in the right session.
And how many people use Azure? Good. What different kinds of configuration management tools do you use? It can be PowerShell, it can be anything else.
DSC, System Center, those are couple of answers we heard. That's okay. Chef is another one. Okay. Can you say it louder? Landisk.
Good.
So basically, in the talk, we'll go through why desired state configuration is a tool that you should care for. What value add does it provide? And then we are going to look into, with Azure and DSC, how they can play better together to solve your configuration management at scale. And towards the end, we are going to talk about complexity to a certain extent so you can scale and keep making changes at a rapid pace.
So, how does DSC help us here? As we saw, in a traditional script, you would have everything defined in the script. What your intent is, what is the dependency resolution, logging, error handling, the technology-specific code, everything is in a single script or a set of scripts. And then, when we enter into DSC, we separate them out. You write configurations which describe the intent. And then there are resources which are pluggable, and that deals with the technology-specific implementation. These resources are PowerShell scripts themselves. And everything in between is handled by the DSC engine. So it gives you nice layering. Most of the redundant stuff about logging, error handling, reboot resiliency, etc., the engine takes care of, and you can write lots and lots of configurations, and your system is configured the way you want it. So, what does DSC give us? It simplifies configuration. It enables you.
Now let's talk about life in cloud. Everybody is moving to cloud. There's a lot of virtualization happening. And cloud is essentially needed for scale. Businesses are growing. You want to scale. Scale means you have more infrastructure to manage, more servers. That means you will have more failures. Additionally, your applications are becoming complicated. They are more complex. So given this multiplication of scale and complexity, that exceeds current IT pros' skills. And the rate at which these things are growing, the skill set cannot grow with the same pace. So that's one aspect. The other aspect is people want to reach to the market faster. They want to capture the market faster. And what does that mean? That means you are churning the code faster. You are making a lot of commits, a lot of change on a daily basis. And again, that's another point which can cause failures. And I think everybody here will agree, when things break, they break because something changed. And this combination essentially leads to rapid change at scale with constant failure from a management perspective in cloud. And that's where DSC comes. It simplifies your desired state configuration as a configuration management platform for Windows. And throughout the talk, we'll not bore you with slides. We'll show you a lot of demos, a lot of PowerShell-related demos, and you will see PowerShell code that you have learned and concepts that you have learned in the last few years. So we'll start directly with demo. See, I told you we'll see demos. So here is a PowerShell, not exactly PowerShell script, but in a PowerShell file, a VB script. And what this script does is it creates an SMB share. And just trying to fit this script in a screen, it goes all the way here. Now, you guys can read all those 95 lines and understand what it's doing, right? So that was the world before PowerShell. Now, in Windows 7 came PowerShell. And here you will see the mix of .NET, WMI, and PowerShell to create the same SMB share using 20 lines. Some progress made. Automation becomes easier, easy to understand maybe. And then in Windows Server 2012, those 20 lines became 1 line. Claps, please.